Okay, hello, welcome back. In the last video, we talked about the concept of hybridization, and today we'll be looking at redox reactions, basically reduction and oxidation reactions, where the major focus is on how to balance the redox equations in both acidic and basic medium. Kindly watch the video, like it, subscribe to our channel, and share with your friends and loved ones who definitely need this. So, let's set out the business of the day. Redox reaction, just like you all know, my outline here says general overview, balancing in acidic and basic medium, which is the main focus of the day. Then sample exercises to practice how to balance these equations. Okay, so let me quickly bring back a quick revision, basically on what is going on in our ongoing post-UTME classes online. Having treated redox reactions, we talked about what the concept of oxidation and reduction is all about. We know that oxidation and reduction can be defined on several bases. On the basis of electron transfer, we know that reduction is what? Is gain of electron, and oxidation is loss of electron. That is by the mnemonic oil link. We know that oxidation can also be defined relative to the oxidation number, where oxidation is the increase in the oxidation number, while reduction is the decrease in the oxidation number. Okay, then we looked at how to calculate oxidation numbers for elements or species in a particular compound. And let me take a quick example. For instance, we have a compound Na2CO3, and then you have to find the oxidation number of carbon. So we know that the algebraic sum of the oxidation number of a compound is going to be equal to 0, right? So we say Na2CO3 is equal to 0. Now we know about the oxidation number of each species in the compound. So sodium here is plus 1, and we have 2 atoms. So that's plus 1 times 2. Algebraic sum, don't forget. So the one we are looking for, let's denote it as x. So then oxygen is minus 2, as the case applies, multiplied by 3. That is equal to 0. So you have plus 2 plus x. Now plus times minus, that is minus 6 equal to 0. So rearranging this, you have x equal to plus 6 minus 2, x equal to plus 4. So this is just a brief revision based on what has been done in the class. And if you think you would be joining our class, you can reach out to us on WhatsApp via the link attached in the description of the video. Thank you. So let's get down to the business of the day. So we're looking at how to balance redox reactions. But then, okay, quickly before we move on to that, you should know about the basic exceptions in determining the oxidation number of certain elements, like your fluorine, irrespective of the compound, the oxidation number of fluorine is always what? -1. Like your oxygen, it is usually what? -2. But in peroxide, the oxidation number of oxygen is always -1. And in your superoxides, like rubidium superoxide, RbO2, the oxidation number of oxygen will be what? -1/2. Now let's get down to the business of the day. Balancing an acidic medium. Basically, a medium could be acidic, basic, or neutral. Just like we have for oxides, we have acidic oxides, basic oxides, peroxides, superoxides, and butyric oxide. So basically, when studying redox, we deal with 3 mediums. The acidic medium, which is denoted by the letter the hydrogen ion H+, or the basic medium, which is basically denoted by the OH- hydroxide ion, and the neutral medium, which is a combination of acidic and basic to give us water. So we're looking at just the acidic and basic medium in this video. So let's get on to business. I'll be using the common and basic examples for this to explain the concept. So let's start with the first example I have here. We have MnO4 minus plus Fe2 plus. The product side, we have Mn2 plus Fe3 plus. So you have to balance this in an acidic medium. Let me take it again. MnO4 minus plus Fe2 plus to give us the product side Mn2 plus Fe3 plus. And let me give you a short overview of the process. In order to balance in a medium, there are about a number of basic steps. The first thing you do is you identify the type of redox reaction happening as the case may be, where there is oxidation, where there is reduction. And the best bet for that is to use the oxidation number, the change in oxidation number. If the oxidation number changes, increasing, that is oxidation, and if it goes down or decreases, that is reduction. So after getting that, you separate your equation into half redox equations. What do I mean by that? You write out the half reduction equation, write out the half oxidation equation. I'll put it through on the board as we are going to solve the example. After that, you balance the atoms. What do I mean by the atoms? There must be equal number of moles of atoms on both the product and reactant side in each of your half equations. And then after that, you're now going to balance up the charges. If it is plus 1 here, it must be plus 1 here. If it is minus 1 here, it is minus 1 here. So after doing that, then you look out for a way to have equal number of electron transfer. So that way, you're also going to do that. And after getting equal number of electrons transferred, the next thing you are going to do is you cancel out the spectator species. Yeah, what do you mean by spectator species? They are like the species in the chemical reaction which are just not necessary for the balanced equation. For example, just relate it to spectators in a football pitch. Spectators just come there to watch how the football match is going to be, but they're actually not going to play the football. So the same way, spectator species are not going to be at the end or overall balanced equation of equation, even though they are very important. So let's set down to balancing this equation. So you have MnO4 minus Fe2 plus. So let's get the oxidation numbers. Now this is MnO4. What is the oxidation number of Mn here? You have MnO4 minus equal to 0, right? So will this be 0? No. Why? The algebraic sum of the whole compound is going to be what? The charge it carries, as the case applies to this. We know about these rules. And okay, so this is going to be, the charge here is minus 1, so equal to minus 1. So you have Mn that we are looking for is X, oxygen is minus 2, minus 2 times 4 equal to minus 1. So X minus 8 equal to minus 2, X equal to minus 1 plus 8. X is what? Plus 7. So not for Mn, this is plus 7. Oxygen we already know is what? Minus 2. Fe here is what? Plus 2. Here is plus 2, and here is plus 3. Okay, so having known the oxidation numbers of each, we can now analyze which one is oxidation, which one is reduction. Look at Mn here, manganese. The oxidation number of manganese here is plus 7. But then after reacting at the product side, it is what? Plus 2. In that case, it is reduction because there is a drop or decrease in the oxidation number. So the half reduction equation is now going to be MnO4 minus to what? Mn2 plus. This is what? Reduction. Good. So the other one is going to be oxidation definitely. From plus 2 to plus 3. So this is oxidation. Fe2 plus to Fe3 plus. This is oxidation. Okay, good. Now having identified them, we go from the reduction part. Redox, reduction, oxidation. Make sure you always go from the reduction side to make it easier and not get complicated. So let's start with balancing. Don't forget, I said the first thing we do is identify your equations. Next thing is what? Balancing the atoms. So for your reduction, you have MnO4 minus to Mn2 plus. Now in this case, we have one manganese, that's balanced. But we have 4 oxygen, there's no oxygen here. So now to balance this, you use a neutral medium like your water. So now there are 4 oxygen atoms here, but there are not 4 oxygen atoms. So you look at it, how many atoms of oxygen, how many atoms of water would you add? The trick is this: for every single atom of oxygen, you add 1 mole of water. For every single atom of oxygen, you add 1 molecule of water. So as the case applies, we have 4 mole of oxygen atoms here. That means we need what? 4 molecules of what? Water. So this is going to be MnO4 minus to give us Mn2 plus what? 4H2O. Okay, so now we have the same number of oxygen, 4, 1 manganese, but then there's also an issue again. The hydrogen is not balanced. So what do? You add the hydrogen in the form of what? Hydrogen ion. So the trick is this: for every molecule of water, you have 2 moles of hydrogen ion. 2 moles of hydrogen for 1 molecule of water. So having 4 molecules of water will require what? 8 moles of hydrogen ion. So you go ahead, you add it. Don't forget, it is this side. So it becomes MnO4 minus plus 8H plus give us Mn2 plus 4H2O. Good. So what do we do next? The Mn is Mn. 4 oxygen, 8 hydrogen, 8 hydrogen. Now it is atomically balanced. Balanced in number of atoms. Okay? So the next thing that follows is what? Balancing it electrically in terms of what? The charges. So let's analyze. This molecule, the charge is what? -1. This one is what? +1 multiplied by 8. That's +8. Now on this side, you have +2, and this is a neutral molecule. So it is what? 0. So the net charge here is going to be -1 plus 8 is what? +7. And here is what? +2. So what do you do? In order to balance this, this is the bigger one, this is the smaller one. So you remove a certain amount of electrons from the bigger charge. So now, in order to make this +7 become 5, what do? You have to reduce number of charge here to what? To 5. To 2 rather. Yeah. So how do you do that? You remove 5. So now the basic analogy is that whenever you are removing electron in order to balance charge, it is plus. It is just like opposite. In order to remove electron, you do plus that particular number. You get? So now this is going to be, we need how many electrons? 5. Don't forget. So this is going to be MnO4 minus plus 8H plus 5 electrons to give us Mn2 plus 4H2O. So now let's look at it if it is balanced now. This is -1 plus 8. This means you are removing 5. So -5. This is +2 plus 0. See, the net charge here is +2. This is -1 minus 5, that's -6. Plus 8, that's what? +2. So the charges is what? Balanced. So this is electrically balanced now. So, well, the first half reduction equation is balanced. Keeping that in mind, now let's go for the oxidation. Okay? The oxidation is not that hard. For the oxidation, you have Fe2 plus to Fe3 plus, right? So, what do you do next? The atoms are already balanced, right? What do you do next? You balance the charges. This is +2, this is +3. So this is bigger, you need to remove just 1 electron. So this is what? Plus electron. So it becomes F. Now, this is already balanced. But then, you have to relate it. Like I said earlier, you balance the number of electrons transferred to be equal on the sides of the reduction and oxidation. So therefore, how many do you have on the reduction side? 5. But you have just 1 here. So in order to balance it, you multiply this by 5. You get? It is easier that way. So you say multiplying this by 5. So it becomes 5 times Fe2 plus, that's 5 Fe2 plus. This becomes 5 Fe3 plus. And this becomes 5 electrons. So now this is balanced. This is as well balanced. So what you now do next is you sum up the oxidation and reduction to get redox. So that's going to be what? On the reduction side, reactant plus reactant, product plus product. So starting with the reduction, you have MnO4 minus. You have what? 8H plus. You have what? 5 electrons plus. What do you have there? 5 Fe2 plus. You are done with the reactant side. So let's move on to the product. We have Mn2 plus 4H2O plus what? 5 Fe3 plus 5 electrons. So now we have that. Okay? Let me kindly clean this up. Okay, now this is our equation. Don't forget, after having it together, you cancel out the spectator species. So now looking at this thing, you look for the stuff that are the same on each side, or if I will put it, I'll just say that collect like terms. So if this +5 comes to this side, it becomes what? -5. +5 -5 cancel each other, right? So you can easily cancel this out with the spectator species. Okay? What other thing is common here? MnO4 minus is not there. 8H plus, do you have anything here? No. 5Fe2 plus, no. So that means every spectator species has been cancelled out. So the balanced equation, balanced redox equation in acidic medium, as it applies, is now going to be what? MnO4 minus plus 8H plus plus 5Fe2 plus, giving us a product size Mn2 plus 4H2O plus 5 verify if this is verified. So you have 1 Mn, 1 Mn, 4O, 4O, 8 hydrogen, 8 hydrogen, 5Fe, 5Fe. It is atomically balanced. How about in terms of charges? This is -1, this is +8, this is +10. So on this side, this is +2, 0, and this is +15. Okay, so this is totally 17. 2 plus 15 plus 17. So this one -1 plus 8 is what? +7. +7 plus 10, that is +17. So that means it is both atomically and electrically balanced. So we are done with the first one. I believe you are catching up and you are getting it. So we'll be going. I'll be taking one more example under the acidic video so as to ensure that you get it properly. Okay. So let's start out the second example here as the case applies. Okay, so writing out the example, we have SO3 2 minus plus MnO4 minus giving us SO4 2 minus and Mn2 plus. Okay, so we are still balancing in acidic medium. So let's go the same way. Identify the reduction and oxidation. So this is sulfur here. This definitely sulfur 6 oxide. So this is +6 -2. This is just the same compound we used the other time. So this is -7, and this is -2. This is tetraoxosulfate 6. Am I right? Okay. So this is +6 -2, and here you have Mn2 plus, which is +2. Okay. Is there an issue? No. Let's confirm for this. This is SO3 2 minus equal to -2. Okay, let's be sure this. I sense there's an error here. So this will be x minus 6 equal to -2. So x equal to -2 plus 6. Yeah, x equal to +4. So this is not my +6. It's going to be +4. Now you should look at how did I detect that? It is not possible for you to have +6 plus 6. That means there's no change in oxidation number. It's not going to be a redox reaction. So that is a simple trick for you. You can identify redox reactions by checking the change in oxidation number. If there's no change in oxidation number, it is definitely not a redox reaction. So now we can dive into the business of the day, balancing it up. So this is +4 to +6, that is what? Oxidation. +7 to +2, that is reduction. Don't forget, always start with your reduction side. So you're going to have MnO4 minus to Mn2 plus. And then, okay, this is reduction. And then you have SO3 2 minus SO4 2 minus. This is oxidation. Okay, so now let's start with the reduction side. So this is MnO4 minus Mn2 plus. Without wasting time, there's 4 oxygen here, there's no oxygen here. For 1 atom of oxygen, 1 molecule of water. So 4 atom of oxygen, 4 molecule of water. This is +4 H2O. Straight up. Okay, now after balance that, how many hydrogen? 1 molecule of water, 2 hydrogen A. 4 molecule of water, 8 hydrogen A. Okay, so now atomically balanced, yes. Mn, O4, 8H, 8H. Now that is balanced. So let's balance the charges. -1 plus 8 plus 2, 0. This is +2 net charge, +7 net charge. What do? You have 5 electrons on this side. Okay? So we have that here to be Mn O4 minus plus 8H plus 5 electrons to give us Mn2 plus 4 H2O. And this is balanced as the case may be. So let's go down to the oxidation part. You have SO3 2 minus to SO4 2 minus. Okay? So now, let me give you this SO4 2 minus. Now 3 oxygen plus 1 sulfur, 1 sulfur. So you need to make this more. So there is 1 extra oxygen here, which requires 1 molecule of water. So this is plus H And for one molecule of water, how many hydrogen is it? Just 2. So now atoms are balanced. So let's balance the charges. You have minus 2, 0, minus 2 plus 2. This is going to be 0, this is going to be minus 2. So what do you do? Between minus 2 and 0, which one is bigger? Definitely 0. Don't make that mistake. So you're going to remove 2 electrons from this side. So that's going to be SO3 2 minus plus H2O, giving us SO4 2 minus plus 2H plus 2 electrons. Now let me give you a simple trick. Whenever you're balancing your redox reaction, and then you discover that both electrons are on the same side, there's definitely an issue. The electrons have to be on different sides in the case of reduction and oxidation, so as to annul themselves in the case of spectator species. Now, don't forget the rule earlier says there must be equal number of electrons transferred. This is 5, this is 2. So what do you do? Multiply this by what? By 5, right? And then you multiply this by what? By 2. I'm right. Yeah. So that is going to be for the reduction side, I'm going to have 2 MnO4 minus plus 16H plus 10 electrons give us 2 Mn2 plus 8 H2O. This is balanced for the reduction. For the oxidation, multiplying by 5, 5 SO3 2 minus plus 5 H2O to give us 5 SO4 2 minus plus 10 H plus 10 electron. So this is ox, this is red, giving us redox. Okay, so now what do? We have everything. The charges are balanced, the atoms are balanced. So we form up reduction and oxidation. So reactant, product. So you have 2 MnO4 minus plus 16H plus 10 electron now plus 5 SO3 2 minus plus 5 H2O. You're done with the reactant side. So for the product side, you have 2 Mn2 plus 8 H2O plus 5 SO4 2 minus plus 10 H plus 10 electrons. Okay, so now yeah, it's quite a long one. Let's write our council of spectator species as case may be. So now looking at it critically, you have 16 hydrogen here, you have 10 hydrogen here. By the time this one comes here, it annuls 16, leaving it behind what? 10. You don't have any MnO4 here, so we're going to start with 2 MnO4 minus plus, from 10, remove 10 from 16, we're going to have 6H plus left. 10 electron, as spectators. Okay? You have SO3, nothing like that, plus 5 SO3 2 minus. I hope this does not confuse us. 5 SO3 2 minus. You have 5 H2O here, 8 H2O here. That means this 5 H2O will go here, right? So it will become 3 at the end. So we don't need this anymore. I hope you get what I did here. This is 5 H2O, this is 8 H2O. By the time the 5 goes here, it's actually going to reduce this one to 3. So we definitely will not have the 5 H2O. Just in case you are wondering why I did not write the 5 H2O there. Okay, so you go to that side, you have 2 Mn2 plus, right? Plus 8 H2O. Sorry, 8 becomes 5 already. It becomes 3. 5 has reduced it. So you have plus 3 H2O. Then you have 5 SO4 2 minus. Okay? What else? 10H plus has already been existed. Okay, let me take it again. You have 2 MnO4 minus here. Now instead of 16H plus, 10H plus reduces it to what? 6H plus. You have 5 SO3 2 minus. Then you have the 5H2 gone to this side. So you have Mn2 plus you have this 8H2 has reduced by 5 to become 3H2O, and then you have F4 2 minus. Don't forget your 10 has been reduced here, so you don't have to look for it anymore. Okay, so what next? Let's confirm if the situation is atomically and electrically balanced. So 2Mn, 2Mn, 4 oxygen here, plus, okay, this is going to be 4 oxygen, and here you have 5 times 3, that's 15, plus 15 oxygen, that's 19 in total. So here you have 3 plus, what do you have here? 5 times 4, that is 20, okay? Oh, sorry, 2 times 4 here, that's 8. That's 8, right? 2 times, this is equal for multiplied by 2, that's 8 oxygen, and then you have 15 here. That is what? 23. And this end, you have 3 plus 20, that's also 23. So the oxygen is balanced, the manganese is balanced. And for your hydrogen, you have 6 hydrogen, 3 times 8, 2, that's also 6. You have your S, 5S, you have 5S. So that means it is atomically balanced. How about electrically? This is minus 1 times 2, this is minus 2, this is plus 1 times 6, plus 8. This is minus 2 times 5, that is minus 10. On this side, plus 2 times 2, plus 4, this is 0 times 3, 0, minus 2 times 5, minus 10. Okay, next side is going to be plus 4 minus 10, that's what? Minus 6. On this end, minus 2 minus 10, that's minus 12. Minus 12 plus 6, that's what? Minus 16. That means electrically it is as well balanced. So we have our redox reaction both atomically and electrically balanced. By now, you should have gotten it properly on how to balance your redox reaction in acidic medium. So quickly before I round up this particular episode of the day, we would be looking at how to balance in basic medium. So there are 2 ways to go about it, and the first method is going through the acidic medium and then neutralizing the hydrogen ion with an hydroxyl ion to give you water and balance it in the basic medium, or going through the normal basic medium. So let me first go ahead with the normal basic medium. So now to balance in the basic medium, the same process applies. Balance atomically, balance electrically. Okay, so let's analyze which is oxidation, which is reduction. Now chromium here is plus 3. Here iodine, let's check out. IO3 minus is equal to what? Minus 1. The charge. So this is X minus 6 equal to minus 1. So X equal to minus 1 plus 6. X is equal to what? Plus 5. So we have plus 5 here, minus 2, minus 1. Chromium here, CrO4, 2 minus 2. So we have X minus 8 minus 2. So X is minus 2 plus 8. That is plus 6. So we have plus 6 minus 2. Okay, quite good. And this is to deal with. So on to the next talk now. Plus 3 to plus 6, that is what? Oxidation. Plus 5 to minus 1, that's reduction. Always start with the reduction, don't forget. So you have IO3 minus to I minus, that is your reduction. And then CR3 plus to CrO4 2 minus, that is your oxidation. Okay, good. Let's start with the reduction part. So you have IO3 minus I minus. Now this is the trick. Don't forget, when balancing with acidic medium, you see for every atom of oxygen, you add 1 molecule of water. But then in the case of basic medium, you're adding to the deficit side, right? But in the case of basic medium, you add to the side with excess oxygen, now to make it balanced. Now this is what happens. You must add the same number of molecule of water as the number of atoms of oxygen that is excess. Now what do I mean by that statement? On this part, you have 3 excess atoms of oxygen, and you don't have any oxygen here. So you are going to add 3 molecules of water to this side. So that will become plus 3H2O. Let me go again. You add the same number of molecules of water to the side that has excess amount of oxygen atom. The same molecules. So this is now making a total of 6 atomic oxygen and 6 atomic hydrogen. Don't forget you are balancing in the basic medium, so you add what? Hydroxyl ion, OH minus. So this is going to become 6OH minus. Let me take it again. First of all, you check the side that has excess amount of oxygen. So that part, the number of atomic oxygen that is excess there is the same as the amount of mole of water that you add to that same side. So that's why you have 3H2O here. As the case may be, you have 6 oxygen. So the number of oxygen will determine the number of mole of hydroxide ion. So 6 oxygen. Now when you look at it critically, there is 1 ion, 1 iodine, there is 6 oxygen cumulatively, 6 oxygen, 6 hydrogen, 6 hydrogen. So atoms are balanced. So balance the charge electrically. This is -1, this is 0. This is -1, this is -1 and 6, -6. So this is net charge of -1, net charge of -7. So which one is greater? Definitely -1. So you remove 6 electrons from this side. So we write it out. That will give us IO3 minus plus 3H2O plus 5 electrons. To give us I minus plus 6OH minus. Right. Okay. Are we good to go? Okay. So, sorry, this is -1 minus 6. That's -7. So we actually need 6 electrons here. Okay. Now going ahead with this, you have to charge this balance. So the reduction part of it is balanced. So let's go ahead with the oxidation part of it. Let's balance the oxidation part. So we have Cr3 plus, you have CrO4 2 minus. So you have 4 oxygen here. So you are going to have 4 H2O, and that will give us a resultant of 8 hydroxide ion. So the charge is, it is atomically balanced. CrCr, oxygen 8, oxygen 8 cumulatively, 8 hydrogen, 8 hydrogen. Okay, now the charges, this is +3 minus 8, how did I get -8? -1 times 8, -8. Here you have -2, here you have 0. So this is -2 net charge, here is -5 net charge. So you need to remove 3 electrons definitely from this side. So having that out, you have Cr3 plus 8OH minus give us CrO4 2 minus plus 4H2O plus 3 electrons. Okay, let's verify we are correct. Plus 3 minus 8, that is -5, -2 plus 0 minus 3, that's what? -5. So it's balanced electrically as well. So our oxidation is balanced, our reduction is balanced. But don't forget, there must be equal number of electrons transferred. So there's 6 here, there's 3 here, definitely multiply it by 2. So that becomes 2Cr3 plus 16OH minus plus to give us 2Cr O4 2 minus plus 8H2O plus 6 electrons. Okay, so now what do you do next? You add up oxidation and reduction to give us redox. So for the reduction, we have reactant to reactant L3 minus plus 3H2O plus 6 electron plus 2Cr3 plus 16OH minus. Now to your product side, we have we have I minus 6OH minus, and then we have 2Cr O4 2 minus plus 8H2O plus 6 electrons. Don't forget the electrons are spectators there, so definitely going out next. Now, just like collection items, there's nothing like IO3 here, so you are still safe to go ahead. It's IO3 minus, right? 3H2O here, 8H2O. That means this goes here. This becomes 5 already. Like that. So this is out. Now you have 2Cr3 plus. Okay, it's not there. So you're going to be plus 2Cr3 plus. You have 16OH, you have 6OH. And this is going out. This is making this 10OH minus. So you have plus 10OH minus. Right? Yeah. So you go to this side, you have I minus, you have CrO4 2 minus, and then you have 5H2O. So let me write it and then confirm if what we have done is balanced. So you have IO3 minus 2Cr3 plus 10OH minus I minus 2Cr O4 2 minus 5H2O. Now let's check atoms. We have 1I, 3 oxygen plus 10, that's 13. 2 times 4, 8 plus 5, that's 13. Balance. 2Cr, 10 hydrogen, 10 hydrogen. Atoms balance. Ions, -1 plus 3 times 2 plus 6 minus 10. Here, -1 2 times 2, that minus 4, here is 0. So this is minus 5, and on this part, minus 1 minus 10 is minus 11, plus 6, that's what? Minus 5. So that means this is a balanced redox reaction in the basic video. Don't forget that also you can go about it in 2 methods. So this is the method 1. I'll be rounding it off on this episode with the second method. So you can choose which of them is more convenient or easier for you. Okay, note the answers by the way. You can tap back in the video and write down the balance equation as we did. So let's take the question again. CR3 plus IO3 IO3 minus give us I minus plus CrO4 minus. So the second method, you balance it in acidic medium and then you neutralize it to give us water. So to balance it in acidic medium, we already know that this is the reduction IO3 minus I minus as it was earlier, and then this is the oxidation CrO4 minus. Okay, this is reduction, this is oxidation. Now let's start with this acidic medium. So if you have IO3 minus, you have I minus, what do you do? 3 oxygen, you have 3 water, you have 3 H2O, you have 6 hydrogen. This is just what we have done in the acidic medium, so I don't think this should be hard. So let's see you balance each of these. Minus 1 plus 6, minus 1 0, minus 1, what do you have here? Plus 5. So as the case may be, you have to remove 6 electrons here to make it minus 1. If you remove 5, that will make it 0. So you remove 6 to make it minus 1. Okay, so that's going to be IO3 minus plus 6H plus 6 electron give us I minus plus 3 H2O. Now that's balanced. Let's go for the oxidation part. Let's go for the oxidation part. CR3 plus CrO4 minus. So 4 of this. It becomes CR3 plus 4H2O, and let's this becomes CrO4 minus plus what? 8H plus. So balancing the charges, plus 3 0, we have minus 2 and plus 8. So this is plus 6, this is plus 3. So you need to add 3 electrons to this side. As the case applies, so you're going to have CR3 plus 4H2O. Give us CrO4 minus plus 8H plus 3 electrons. Now, equal number of electrons transferred. So you multiply this equation by what? By 2. So it becomes 2CR3 plus 4H2O. Sorry, by 2 as plus 8H2O. We have 2CrO4 minus plus 16H plus 6 electrons. So add it up together. That's going to be from here we have IO3 minus. Don't forget all of this is in the acidic medium. So IO3 minus plus 6 H plus 6 electron plus 2CR3 plus 8 H2O give us what do you have here? I minus plus 3 H2O plus 2CrO4 minus plus 16H plus 6 electrons. Now you still have to finish up everything. This is 6 6 here goes out to make this one 10H plus. Then what about the water? You have 8 here, it becomes 5 due to this one 3. So writing out everything, I'm going to have IO3 minus plus 2CR3 plus 5H2O give us I minus plus 2CrO4 minus plus 10H plus. And this is already balanced in the acidic medium, but then the question says you should balance it in basic medium, but this is in acidic medium. So what do you do? We have IO3 minus plus 2CR3 plus 5H2O, right? Plus I minus plus 2CrO4 minus plus 10H plus. So in order to balance it in basic medium, you add equal number of hydrogen ions. Equal number of hydrogen ions as you have for hydrogen ion. That is, you have 10 hydrogen ions, so you are going to have the same number of hydrogen ions to balance it in the basic medium. So that means we are adding 10 hydrogen ions to both sides plus 5820 plus 10OH minus. This is on the reactant side. Then you have I minus plus 2CrO4 2 minus plus 10H plus 10OH minus. So now, let's see what we can do. H plus and OH minus will give us water. So let's come back. We have IO3 minus 2Cr3 plus 5H2O 10OH minus I minus 2Cr4 2 minus plus what? This is going to be 10H2O. Yeah, so that's going to be 10H2O. So now what do we do? Spectator, this is 5, this is 10. So this is going to have to give us 5H2O. So the balanced one is going to be IO3 minus 2Cr3 plus 10OH minus I minus 2Cr4 2 minus 5H2O. Now you can check up the answer I told you to write down earlier for the first one. If it is the same thing. But even if it's not right now, let's check if it's balanced. 1I, 1I. Oxygen here is 10 plus 3, 13. Oxygen here is 8 plus 5, 13. Chromium is 2, chromium is 2. Hydrogen is 10, hydrogen is 10. Charges, minus 1, plus 6, minus 10. Minus 1, minus 4, 0. Minus 5, minus 1, minus 10, that's minus 11 plus 6, which is minus 5. So it is electrically balanced as well. So as the case applies, you can balance your medium using acidic medium or basic medium. So that video will be rounding up the episode for today. So you can give me feedback in the comment section, especially on this basic medium. Which of the methods do you think it is easier for you? Is it the first method or the second method? You can give me a comment in the comment section. Don't forget to like this video, share and subscribe, and follow up for other updates. Like I said earlier, you can get the link to our post in the description link of the video. Thank you very much, and see you in the next.